So let's look at e to the x. Let's begin with e to the x over here. So y equals e to the x. We know when you do dy over dx, what do you get? E to the x. Okay? But on here we could also use the chain rule. Because if I had y equals e to the 2x plus 1, for example, what I could do is say let the 2x plus 1 equal u, and so y equals e to the u. In that case, the dy over du would be what? E to the u. But the du over dx would be what? U is 2x plus 1. 2. And therefore, applying the chain rule, where dy over dx equals dy over du times du over dx, gives me 2e to the u, which is 2e to the 2x plus 1. Is that okay? So that's all we've done. We just applied the chain rule to a function of a function. In this case, the function happened to be a power of x. Now we can extend this rule to say if we've got y equals e to the kx, then dy over dx is just going to be what? We can e to the kx, but what else? K times e to the kx. Can you see that where that's coming from the chain rule? So e to the u, guys could just quite notice. So e to the kx is your u part, and you differentiate in that kx to give you k. And when you multiply them out, you end up with e to the kx. Is that okay for everyone? Go on. Yeah, but here we've got e to the kx. Yeah. And it's different because of the chain rule that we've just put up. Because what we've done, the power part has become the u. Because it's not a straight x, it's 2x plus 1 or 3x squared plus 1. So we've said, right, let's just simplify that problem. Okay, instead of turning it into lots of powers or e2x times e to the 1, and you add the powers, let's just make the whole power 2x plus 1 into u. Okay, so we're doing a function of a function. So the bracket part is our u. Okay, and then so you're differentiating. So now you've got a new problem, e to the y equals e to the u, which is straightforward. We know dy over du is just e to the u. That's
so anything where it's a number to the u, dy over du is always the same.
Yes. Anything where it's e to the power of a single variable.
What about 2 to the power of each single variable?
2 to the power of a single variable. So 2 to the x.
So yeah, so 2 to the u. dy by du, what would that be? 2 to the u.
No, then that opens a different thing altogether, because what we're considering at the moment is e to the x. The reason why we're looking at is the gradient of e to the x is always the same. Yeah?
So this only applies in e to the x?
Yeah. Alright, now what we could do, can everyone look up, is we can extend this result to say, pretend we had y equals e to the fx. So now it's not even kx, it could be any nasty function, e to the sine x plus 3, could be something like that. Then our dy over dx is going to be what? E to the fx. Can you make sure you've copied that down and that's explicitly clear? So I'll put that in a little box for you.
Are we going to do differentiate and signing that?
Yeah, yeah, later on, not this lesson though. Okay. All right. Let's now, I'll leave the top part up there, so if you just copy that down. Okay, can everyone look up for this? Even though I was working ahead, can everyone look up? Right, let's now look at the derivative of Linux. This is quite interesting. Okay. How does if you know how to do the derivative of Linux? How to derive it? You know how to work it out? Okay. Yeah, no, you can derive the actual derivative. So you know how, okay, fair enough. Right, let's start by working out y equals Linux, and we don't know what the derivative of Linux is at the moment. There is no standard sort of, formula we can use to just differentiate Linux. So what we're going to do is do a little trick. We'll take the exponentials of both sides, and that will lead us to e to the Linux will give us what? X. It just gives us x. Thank you, Usman, because the inverse is an inverse function. You done the function, you do the inverse, you're left with what you started off with. So therefore, e to the y equals x. Or said another way, x equals e to the y. Now watch this. What we could do is differentiate both sides with respect to y. So what we could do is d over dy equals d over dy e to the y. When I differentiate e to the y with respect to y, guess what I'm going to get? E to the y. So now I've got a new rule. I've got dx over dy is e to the y. Now using that flip, Alex, using that flip that I think you was asking me about earlier on, it comes into play here. Because then if I've got dx over dy is e to the y, dy over dx will be what? E to the minus y, which is 1 over e to the y. But we know y is the same as what? What's y the same as? Ln x. So if I was to write this down, let me just write it, let me just continue here. So I've got dy over dx equals 1 over e to y, which is 1 over e to the ln x. E to the ln x is what? It's just x. So therefore I've got 1 over x. Here it is, okay? So if I differentiate my y, I get 1 over x. Okay, and we'll look at more into this when we start doing the integrals as well, because then it comes into play quite a bit when you look at the integration of certain functions. Okay, so what is probably worth copying down is we can write down dy over dx equals, so if y equals ln x, then dy over dx is 1 over x, and that's the result we need to be aware of. Yeah.
I didn't get a bit at the start.
Yeah.
How does e to the y equal x?
E to the y equals x, because we've started off by saying y equals ln x. We want to differentiate this.
Yeah.
We can do dy over dx, but when we do d over dx, we don't know what's going to happen to the ln x at this stage. So what we do is we can take the exponentials of both sides.
So that's e to the y equals.
Yes. And that's why you get e to y. And I've just written it the other way around, x equals e to the y.
Oh, yeah, yeah.
And then I'm taking the derivatives of both sides with respect to y. Okay. And that we just know is e to the y, and then I've played around with it. Is that okay, Matthew? Okay with that?
Yeah.
Okay. Right, what I'm now going to do is put 6 examples up. You know the maths behind it. You've done product, you've done quotient, you've done chain rule. Okay? I'm going to put 6 examples up. 3 for exponentials, 3 for logs, and I'll put down the final answers as well. I do expect one or two of them will be straightforward. You just do it like that. You can look at them and just work out the answer. 1 or 2 of them will hopefully challenge you, but obviously sit as a group so you can discuss, and then we'll go over it later in the lesson. So let's have a go at doing these 3 questions. Let me put up firstly this one here. Okay. And let's also put up these ones here. Okay. And I'll put up the final answers to both of them in a second.